welcome to Night Sky News for March 2021 with me, astrophysicist Dr Becky Smethurst. This is the series where we chat about everything that you should look out for in the night sky in the coming month and everything that's been happening in space news in the past month. So without any further ado, let's kick things off and start by looking up. Now, first up, on Friday, the 19th of March, the sort of crescent / half moon is going to be pairing up with Mars in the constellation of Taurus in the evening sky. Now, you want to look for this in the southwest or the northwest if you're in the southern hemisphere, out of whatever window that you see the sunset from, essentially. So obviously the moon's going to be a really good signpost for where this is in the sky, but if you're looking for Taurus normally, I find it easiest to just find Orion first because it stands out the most with Orion's belt, and then use it to pick out Taurus sort of above and to the right of it a little bit. You're going to have the red star Aldeberan, which is supposed to be the bull's eye of Taurus, and it's going to be making a triangle with the moon and Mars. And then from there you can see if you can pick out that classic Y shape of the bull's horn of Taurus. Then this weekend on the 20th of March, we've also got the equinox, the spring equinox in the northern hemisphere and the autumnal equinox in the southern hemisphere. So this is when neither the North Pole or the South Pole is pointing towards the sun, and we have roughly equal day and equal night all around the world. But one thing I want to highlight that a lot of people don't realize is that on the equinoxes, the sunsets and the sunrises are the shortest they get throughout the year. Maybe most people don't even realize that the sunsets and sunrises do take different times throughout the year, but it's all to do with the angle that the sun comes in at the horizon. On the equinox, it sets directly in the west and rises directly in the east. So if you think about it, that on the equator, that means that the sun sets directly vertical with the horizon, and so it appears to set very, very quickly. If it comes in at a more shallower angle, it appears to take much longer. So for example, in the UK on March 20th, the sunset takes around about 3 minutes 40 seconds-ish. Whereas on June 20th, in the middle of summer on the solstice, it takes about 5 minutes 40 seconds. So that's a 2-minute difference in the UK. So that's a fairly noticeable length of time that you might notice that changing in. Now, fair enough, the further you are from the equator, the bigger the difference in length of sunsets at the equinox compared to at the solstices you will actually experience. On the equator, it's something like 2 minutes 15 seconds on the equinox, whereas in the solstice, it's 2 minutes 30 seconds. So it's only a 15-second difference, but it's one of those things. If you're chasing sunsets and sunrises at the minute, they are going to be quicker, so don't just blink and miss them. Then just after Easter on the 6th and 7th of April, we've got my favourite things in the sky. We have got a toenail moon with Jupiter and Saturn just before sunrise. So we'll have switched into daylight savings times here in the UK. So the sunset's going to be fairly early still. So it's going to be about 6:30 or so. Don't know if I'm going to be up at that time, but if you are, then look out of the window towards the southeast if you're in the northern hemisphere, or the northeast if you're in the southern hemisphere. Whatever window you happen to, see the sun rise out of, or whatever room gets the morning sun, and you should be able to spot this. So on the 6th, the moon's going to be closest to the fainter of the two planets, Saturn, and then by the 7th, it'll be closest to Jupiter. Now, you're going to need a fairly decent telescope to be able to see any sort of detail, like the striping of the bands on Jupiter, or say the rings of Saturn. But if you've got some fairly decent binoculars, you should be able to see the 4 biggest moons of Jupiter, the Galilean moons. I know I can see them with my binoculars, which are the 15 by 70 Meads. They're fairly heavy though, so I'd recommend people get a tripod if you are going to get some of these. I know my little noodle arms find it difficult to hold them steady when I'm looking at something like Jupiter, so get a tripod. But if you're lucky enough to have 2 clear mornings in a row, then what you should look for is the positions of Jupiter's moons actually changing. So you can see this from one morning to the next. For example, Io only takes 42 hours to go around Jupiter, so you should be able to see it shift position 24 hours from when you saw it last. Speaking of moons and toenail moons and Saturn as well, check out this incredible image that one of my subscribers, Louis Contreras, sent my way on Twitter. This is Saturn's moon Dione taken by the Cassini probe way back in May 2010, and it too looks like a toenail. All right, that's enough for looking up at the beautiful night sky. Let's come back down to Earth now and chat about what's been happening in space news in the past month. All right, the big news this month was, of course, that NASA's Perseverance rover landed safely on Mars. This wasn't a given, about 50% of Mars landings have failed in the past, so it was a bit nail-biting if I'm honest, but the astro community breathed a rather large sigh of relief when touchdown was confirmed. This was my live reaction, and of course we had that first image that was sent back as well, and we can allow the sound of the Martian wind that it picked up with its 2 microphones to just wash over us and calm us during these unprecedented times. But let's not get distracted by the over 7,000 images it sent back since it actually landed, and let's talk about science. What has Percy been up to, and what have the science team behind the mission been up to as well? Mostly, they've just been checking that everything is okay. Percy went for a drive, so 4 meters forward, it turned 150 degrees left and then reversed for 2.5 meters. Like it was just reversing into this non-existent supermarket parking space on Mars. I don't know why. We've also been able to deploy the 2-meter-long robotic arm as well and checked all of its 5 different pivot joints are in working order. They've checked the radar imager is operational that they're going to use to map out the terrain underground, and they've checked the MOXIE instrument, which is the one that will be used to try and produce oxygen from the Martian atmosphere, and that all seems to be working okay as well. Plus, the wind and the weather sensors have been deployed too, which are now actively taking data as we speak on the temperature, the humidity, the wind speed, the wind direction on Mars. Now, another instrument that's been tested and found to be working okay is the SuperCam instrument, and that's actually been able to send us back the first science result of the Perseverance mission. So SuperCam is a combination of a camera, a laser, and a spectrometer, which is a device that essentially lets you work out what elements are present in a material. So SuperCam has sent back a few super close-up images of some rocks on the surface. The first was dubbed Yikigo. It looks incredible. You can really see this like granular structure or texture to it, even though this was actually taken from over 3 meters away. You can really see the sort of scale of it in this image. Now there's another of these super close-up images that's come from SuperCam as well, and this one is of a rock dubbed Maz, which is the rock that they fired SuperCam's laser at for the very first time. You might have actually heard the audio clip that they recorded of this laser being fired on the news. It sounds pretty cool, and what you can hear there is actually not the laser being fired, but the laser striking the rock, Maz, that it's actually being fired at. And you can hear that there is actually a slight difference in the loudness of the sound of the laser hitting the rock if you listen to it. And that difference is essentially like the hardness of the rock that it impacts. The harder it is, the louder the sound that it makes. And what that allows us to do is determine what some of that Martian rock around the Jezero crater where Percy has landed is actually made of. So it's really exciting because it means we've already got the first piece of science from the Perseverance mission, because SuperCam has managed to figure out that this rock, Maz, is a basalt, i.e. it's volcanic. So it's either one of 2 things, right? Either it's a purely igneous rock that's made by a volcano, or it's made of like igneous grains of rock, like sort of like volcanic sand, if you will, that have all sort of been compacted and compressed together into sort of like a cement-like structure by the water that we think used to be in this lake bed where you find Jezero crater, at least before Mars lost all of its water to space a few billion years ago. So this is exciting stuff, right? Not only is it the first ever laser fired on Mars, but it's also the first scientific discovery to come out of the Perseverance mission as well. Of course, it's just a scratch.
'Tis but a scratch.
In terms of like how much science Perseverance still has left to do, and it's definitely going to turn its focus to this mission of astrobiology, searching for evidence of past life on Mars if there was any. Plus, it'll soon be testing the helicopter drone that got sent with Percy as well. A real sort of Wright brothers moment, right? The first flight on Mars. If it works, of course, it's not a given that Ingenuity will even be able to fly. And incidentally, this one's been nicknamed Ginny as well, which I think is my just favourite part about this whole mission, is that we've got Ginny and Percy on Mars. We've got 2 of the Weasleys on Mars. So I'm just going to start this petition now to name the next mission to Mars Rendezvous, so that we can nickname it Ron and get another Weasley on Mars.
Another Weasley. I know just what to do with you.
All right, that's enough about Mars for 1 month. Let's talk about neutrinos and black holes now. So back in 2019, the Ice Cube Observatory at the South Pole detected a neutrino with so much energy that it was very likely it had come from outer space. Now they managed to triangulate where in the sky this high energy neutrino had come from. And that doesn't exactly give you the most accurate of directions. It's actually quite a large swath of sky that you end up with. But in that area of sky, there happened to be a TDE, a tidal disruption event. Now that's a very boring name for something that's really, really cool. This is when a star passes too close to a supermassive black hole, and because the forces of gravity are so strong, it gets spaghettified, i.e. it resembles less of a star and more like a really long string of spaghetti. Now, some of the material from that disrupted star actually ends up spiraling around the black hole, and where it gets accelerated to these huge, huge speeds, which causes it to heat up and it starts to glow with light. At least before it crosses the event horizon, it's accreted by the black hole. The black hole uses that mass to grow, and that material is literally never seen again. Now, there's been a lot of theoretical studies that have said this process of accelerating that material around the black hole could actually produce these high energy neutrinos. But obviously the Ice Cube experiment team were a little bit wary of declaring that that is exactly what they found when they first found this neutrino back in 2019, because it could have just been a fluke, and it might not have actually come from this known tidal disruption event in the area of sky that they thought this neutrino came from. It could have come from something else. But Ice Cube has since detected another neutrino coming from the same place in the sky, along with the flare of radio light from this TDE at the same time. So Stein and collaborators this month actually published a paper describing this detection and pointed out that this hypothesis of TDEs, these tidal disruption events, the spaghettification process, maybe producing these high energy neutrinos, is looking a lot more likely now with their observations, which is really exciting, because if we could study these neutrinos and their properties, they come from right down close near the event horizon, right before you'd have to be traveling, at the speed of light to escape the pull of the black hole. So it can tell us a lot about that region. So I'm really excited to see if they detect any more of these things and what we could learn from them. Now, while we're on the topic of supermassive black holes, it is my favorite topic after all, let's talk about our own supermassive black hole, the one at the very center of the Milky Way that we are all currently orbiting around right now. Now, we know that the Milky Way is eventually going to merge with the Andromeda galaxy. The two are slowly moving towards each other under gravity, and when they finally meet and merge, the two supermassive black holes at their centers will also merge as well. Now, we can estimate how long this process will take if we sort of model the merger of the two galaxies, but we need to know how fast the Milky Way and Andromeda are actually moving towards each other. And we need to know sort of like what angle they're going to come at each other as well. Is it going to be like a head-on collision, or is it going to be more of like a glancing blow where the two sort of orbit each other for a while and eventually sort of slosh to the middle? So we can get the speed at which Andromeda is moving directly towards it by how much its light is Doppler shifted by. So essentially how much that light wave is squished to shorter wavelengths because of the speed that Andromeda is moving towards us. The same way that an ambulance siren, its pitch, it increases as it's moving towards you because the sound wave has been squashed to higher wavelengths, which are higher pitched sounds. Now the problem is that only gives us the speed at which Andromeda is moving directly towards the Milky Way. It doesn't give us the speed in other directions that it could be moving. For example, left and right, or up and down. That's something we call the tangential velocity, because it's moving at a tangent to the direction towards the Milky Way. And this is a big deal, because if Andromeda has a very big tangential velocity, that could take it sort of out to the side of the Milky Way, giving you that situation where you have a much slower merger where the two things sort of spiral around each other and eventually slosh together in the center, rather than like a direct head-on collision where you don't have any of this tangential velocity. And so when we model this happening, this actually has huge consequences for how long this merger would take, and also what happens in the merger of the supermassive black holes as well. So this is what Schiavi and collaborators published this month. They published a paper describing what they found when they modeled this merger happening for the galaxies and the supermassive black holes with various different tangential velocities. And they found that the time it takes for the black holes to merge could range anywhere from 5 billion years or even up to 20 billion years for these two supermassive black holes to merge. So this means that the sun, which is a fairly middle-aged star, it's got roughly 5-ish billion years left before it runs out of fuel, it might not be around to see this eventual merger of the Milky Way and Andromeda and their two supermassive black holes. And by extension, Earth won't be either. All right, one last fun thing that people outside of the UK might not have heard of this month. So on Sunday, the 28th of February, an incredibly bright meteor known as a fireball blazed across the sky at around 10 p.m. And because this is 2021, it was spotted on doorbell cams and dash cams across a huge patch of the south of England. And with all of the footage and the exact locations of those cameras, astronomers were essentially able to recreate the path that this fireball took through the sky and therefore pinpoint the area where it should have landed. And they managed to narrow it down to the Gloucestershire area, somewhere north of Cheltenham. And thanks to a dedicated search and getting the news out to the public, loads of fragments have been found in places like people's drives and to farmers' fields. And this was incredibly exciting, right? Not only because it was the first known meteor to have landed in the UK since 1991, but it also turned out to be an incredibly rare type of meteor called a carbonaceous chondrite. Of the 65,000 meteorites that we've collected over the years as they've fallen to Earth, only 51 are these carbonaceous chondrites. They're actually thought to come from asteroids that formed in the very early days of the solar system. So they're sort of like relics or fossils of what the conditions were like back then, 4.5, 5 billion years ago. Now, the chunks they've got are very fragile. They've been described as looking almost like coal. And it's this fragility that got a lot of people excited because that would have broken up in space if it had been that fragile. So there must have been something else holding it together. And a lot of people have suggested, well, it could have been ice, like water ice. And so that feeds into these ideas, this hypothesis that asteroids and comets could have been the things that brought the first water to the very early Earth. Now, I've seen a lot of media reports commenting on how this kind of meteorite is what OSIRIS-REx was sent to Bennu to collect and then return to Earth. And of course, Hayabusa 2 as well was sent to Ryugu, and that returned its sample back in December 2020. And all these reports were saying, oh, they were sent all that way and one's just, happens to have fallen in the back garden. But what we have to remember is that falling through the Earth's atmosphere is massively going to have contaminated this meteorite. And also sitting in a farmer's field for a couple of days will definitely have contaminated it. Whereas the sample that's been returned by Hayabusa 2 and hopefully will get returned by OSIRIS-REx in a few years, they're essentially going to be kept like quarantined, if you will, right? They'll be kept in a vacuum, away from any contamination from any Earth-based sources, kept as pristine as possible. But what this meteorite that's fell in the UK will allow people to do is essentially have a bit of a trial run, really, to kind of like decide what tests and experiments they want to do on the pristine sample that they'll probably have a lot less of. So, they really need to go in with like a game plan. So this meteorite will essentially let them figure out their game plan of what they're going to do with the Hayabusa 2 sample and what they will eventually do with the sample from Bennu that OSIRIS-REx is returning in 2023. So I guess we just have to be a bit patient while all of that goes on. But I'm so excited to see what they're going to find and if they're going to find more evidence for this hypothesis that the first water was brought to Earth by asteroids and comets. All right, that's it for this episode of Night Sky News for March. I'll be back next month with April's Night Sky News, but until then, if you want to follow me on social media for sort of like a live reaction to space news as it comes in, you can find me on Twitter and Instagram. Also, if you liked my t-shirt, then check out my merch in the video description down below. Never mind stars in your eyes. I have a whole galaxy in mind. All right, that's enough for looking up at the beautiful night sky. Let's come back down to Earth now. What's up with my voice? Which is possibly my favourite thing about this whole mission is that we've got both Ginny and Pursley, It was Persley. It's like Percy and Parsley put together. In that area of sky was something known as a TD... Damn you, Chair. First, or like maybe they'll find something in this carbonaceous chondrite meteorite. Carbonaceous chondrite meteorite. And that is a mouthful.